We've got it. I know we've got it because my teammate is drawing the same line I'm drawing from two different angles, and we're going to meet in the middle. We've been at this whiteboard for most of the morning. We filled 3 pages. We've gone through 2 markers. The cap on one of them is missing and has been missing since approximately 9:30, and we stopped carrying at noon. We are 2 junior engineers fresh out of college working at a defense contractor, and we're solving a hard problem. The system is written in a mix of languages that I will describe only as close to metal. Very close. Like I can feel the processor breathing close. And there's this loop that has to run at least once, then check a condition before it runs again. And we can't find a clean way to do it in the code we're working on. So we've been thinking in assembly, just a little assembly, just enough to make the loop perfect. And we have done it. The logic is there. It works. We know it works. We've traced through it by hand 4 times. It checks out every time. We look at each other and we walk to our tech lead's desk and we present our solution. And he looks at us for about 3 seconds. You mean a do-while? Welcome to Chaotic Commits. I'm Joanne, an engineer, professor, AWS community builder, and someone who once independently invented a construct that had been in C standards since 1972. Just a quick history detour here, and I promise it's relevant. In the 1660s, Isaac Newton developed a new branch of mathematics for describing rates of change. He called it the method of fluxions. About 10 years later, Gottfried Wilhelm Leibniz, working separately in a different country, knowing nothing about Newton's work, developed the exact same mathematics. He called it calculus. 2 people, no communication, same answer. In 1858, Charles Darwin received a letter from Alfred Russel Wallace. Wallace had independently developed the theory of natural selection while recovering from malaria in the jungle. Darwin had been working on it for 20 years. They presented it jointly to the Linnean Society that year. 2 people, no communication, same answer. In November of 2010, 2 junior engineers at Lockheed Martin, working in a conference room with a missing marker cap, independently developed a loop structure that checks a condition after execution rather than before. 2 people, no communication, same answer. The answer was already in every introductory programming textbook since approximately the Eisenhower administration. Now, before anyone emails me, no, I'm not comparing inventing calculus to forgetting a programming construct. The comparison ends at the very human moment of, wait, someone already solved this. So today's episode is Feet invented the do-while loop, already existed. And I want to talk to you about what it actually means to be smart, but not yet experienced. The difference between having the vocabulary and being able to reach for it. And the system failure that leaves junior engineers alone in a room until they reinvent things from scratch. But mostly I want to tell you about the day we thought we had done something impressive and the tech lead who corrected us in 4 words. And why that story is a lot less embarrassing than it sounds. So let me set the scene properly. This is my first real job. I have a master's in computer science degree, a lot of enthusiasm, and exactly 0 production scars. I know algorithms, I know data structures, I can write code that passes a test suite. I know what a do-while loop is the way I know what mitochondria is. I can write it on a test, and I've done absolutely nothing with it since. My teammate is in the same boat. Same age, same background, same set of things we learned in school that we have not yet encountered in the wild. We're working on a defense system. I will tell you almost nothing about what it does because some of it I just don't remember. And some of it was because it was not supposed to leave the building. What I can tell you is that it involves low-level code. It's performance sensitive, and the code base is the kind of thing where comments are dated 1998 and the person who wrote them has been gone long enough that asking about it feels like holding a seance. Nobody told us to go figure out this particular problem. Nobody assigned it to us. We found it, recognized it was a problem, and took it upon ourselves to solve it, which, in retrospect, says something about our good instincts. We were engaged, we cared, we looked at a weird loop structure, and instead of shrugging and moving on, we said, this could be cleaner. We were also completely unsupervised. Not in a negligent way, in the way that defense contracting sometimes works, where there are multiple projects running, multiple deadlines, and the senior engineers are mostly on fire in a different room. There was a tech lead, he existed, he was busy. Nobody had checked on us in about a week. Here's what I want you to understand about two engineers left alone with a hard problem and no one to ask. We will figure it out. That part is not the problem. We are competitive with ourselves, we have been trained to find the answer, and we have nowhere to be until 5 o'clock. We will work on it until we have something. The problem is that we will find the answer the long way. We will not Google do while loop because we will not know that this is the phrase to type. We will think about the problem in terms of what we're working close to. Assembly, machine instructions, explicit conditional branches. And we will build something that expresses the correct logic in the vocabulary we have available, which in this case is more code than necessary, arranged in a way that is technically correct, and also the engineering equivalent of building a chair out of individual planks when the furniture store is right down the street. So we'll come back to that. First, the whiteboarding. We spent about 2 hours on this. I want you to know that we were very serious about this. We had a real problem. We solved it correctly. The logic was sound. We weren't doing anything wrong. We were just doing it without the benefit of knowing the name of the thing we were building. Just imagine for a second, have you ever tried to just describe something when you don't know what it's called? Like you're in a foreign country and you need something specific at a pharmacy and you don't know the word and you end up gesturing and describing the function of the thing, and eventually the pharmacist says, "Oh, bandage," and hands it to you, and you want to die a little, but also the problem is solved. That is what we're doing with a loop. We're essentially describing, in assembly language and a lot of diagram arrows, the precise function of a bandage. We knew what it did. We knew how it worked. We had traced through the logic 4 times and confirmed it was correct. We just never encountered the sign that said, bandages aisle 7. So let me explain what a do-while loop is for anyone who's not a programmer, because the humor requires you to understand exactly how basic this thing is. A loop is a piece of code that repeats. That's it. You do something multiple times. That's the entire concept. Most loops check the condition first. If this thing is true, run the code, then check again. If it's still true, run it again. And you keep going until the condition is false. A do-while loop does it in a different order. You run the code first, then you check the condition, which means the code inside the loop always runs at least once, no matter what. That's the difference. Run, then check versus check, then run. To make this maximally concrete, imagine you have an alarm clock. A regular loop is you need to be up at 7, set the alarm, and see if it goes off. A do-while it is the alarm goes off, now you check if you need to be up. You are already up. The do-while is used when you know you need to do the thing at least once. Check your password, validate your input, read from a sensor. The action always happens. The question is just whether you do it again. This has been a solved problem in programming since before I was born. Specifically in C, which is the language from the early 1970s, also in ALGOL, which is from the 1960s, also in assembly, which you can write yourself in whatever architecture you prefer, which is exactly what we were attempting to do, unknowingly encoding a loop structure that has had a name for longer than most cars on the road. The thing that makes this story work, the thing that makes it actually funny, rather than just embarrassing, is that we got the logic completely right. We arrived at exactly the correct structure for what we needed. We traced through it by hand. It was sound. We weren't confused about the problem. We weren't solving the wrong thing. We just expressed it in approximately 4 times more code than necessary and gave it no name because we didn't know the name existed. We built it from scratch in a defense contractor's conference room in Florida, a correct implementation of a programming concept that Dennis Ritchie had formalized before either of us started school. Newton and Leibniz, as I mentioned, both independently arrived at calculus. Then they spent years in an extremely petty dispute about who got there first, which I find comforting. Neither of us did that. When the tech lead said, "You mean a do-while loop?" we looked up, confirmed that yes, that was exactly what we built, and then we sat with it for a minute. And I'm going to describe that minute accurately. It's a specific feeling of having worked very hard to open a door, and then someone points out that there was also a door handle. You had been pushing with both hands. The handle was there. You got the door open. The door is open. It's just that there was a faster way and you didn't know about it. That's not a bad feeling to have at the beginning of your career, by the way. So here's what I actually think happened, which is a different question of what it looks like from the outside. We knew what a do-while loop was. And I want to be clear about that. It was in the textbook. I've written at least one in a programming class. If you had said the words do-while loop to me on the street, I would have told you correctly what it was. What I didn't have was the firing mechanism, the index entry, the connection between I have this specific loop problem where I need to execute at least once and then check a condition. And oh, that's what a do-while loop is for. This is a thing that doesn't get talked about enough. Knowing a concept in isolation, able to define it, able to write it on a test, is not the same as being able to reach for it in the field. That's the gap between knowing the word and knowing when to say it. Senior engineers don't have more intelligence. What they have is a pattern library, and the index is built. When they see a loop problem, the word do-while surfaces automatically because they made that connection in enough context that it's automatic. For us, we have the entry in the dictionary, but the search index hasn't been built yet. You build that index through exposure, through reading other people's code, through code review where someone says, "Have you thought about using a do-while here?" Through working on enough problems that the pattern fires reliably. We had none of that. We had been left alone in a room. And here's the part I think that matters. That wasn't our failure. That was the system's failure. 2 junior engineers at the beginning of their real job handed a hard problem, pointed at a whiteboard, and left to figure it out. No documentation, no code review, no one checking in to say, before you go build something from scratch, have you looked at what constructs the language already gives you? Nobody asking, what have you tried so far? The tech lead was busy. He wasn't wrong to be busy. But there's a difference between not having time and not having a process. And what we didn't have was a process that would put someone in that room with us for an hour before we spent 2 days reinventing something that already existed. I have been a tech lead. I've been a director of engineering. And when I think back to the story from that perspective, the question I ask is not, why didn't those junior engineers know about a do-while? The question is, why were we alone? The knowledge sharing, that handoff of vocabulary from experienced to inexperienced engineers is not nice to have. That's the actual job. It's what separates a team from a collection of people working in parallel. Two smart people in isolation will arrive at correct solutions. They will just arrive at them slowly. They will express them in more code than necessary. And occasionally, they will spend 2 days building a do-while from scratch. Give them the prior art, or at a minimum, give them a person who has the prior art for 1 hour before they start. And this story is from 2010. The interesting question is why this failure mode shows up again today, especially now. The person in the room is sometimes the AI assistant. Vibe coding, and I'm not saying this meanly, it's just a description, is the two engineers in a room. It is the intelligence without a vocabulary index. A model can generate code that is structurally correct for a given problem and express it in 4 times more code than necessary because it doesn't know the name of the primitive, and neither does the person reviewing it. AI does not remove the need for engineering judgment. It makes the absence of engineering judgment much harder to hide. I've seen production code reviewed by junior engineers who used an AI assistant and got back something that worked. It passed the test. It was a do-while written as a while loop with a bool flag and a pre-execution side effect. Nobody caught it because nobody knew what to look for. The flag shipped, the code ran, and the debt accumulated. The do-while problem doesn't go away when you give people a smarter tool. It goes away when you build the vocabulary index, and the vocabulary index gets built by mentorship, code reviews, and working next to people who have the words for things. Here's what I want you to actually take from this. We didn't fail that morning, and I want to say that clearly. We saw a problem. We worked on it seriously. We arrived at the correct logic. We traced through it by hand multiple times, confirmed it was right. We walked to our tech lead and presented it, and he gave us the word for it. That's not a story about bad engineers. That's a story about engineers who were doing exactly what engineers are supposed to do without the one thing that would have made it faster: someone to tell them the name. The history of computing is full of people who built something that turned out to already exist. Some of them named their thing anyways, and it became important. Most of them looked it up, learned the name, and moved on. We moved on. My teammate and I still talk about it. It's a really good story. We like to commiserate over other fun stories like that. It's a better story than we looked it up and moved on without incident. There's something to be said for arriving at an answer from first principles. You understand it differently when you get there yourself. I have never looked at the do-while loop sets that afternoon without knowing, at the level of trace-through whiteboard logic, exactly what it does and why. That understanding is not academic. I built it from the metal up in a conference room in Florida with a missing marker cap. The embarrassing part was never the discovery. The embarrassing part was the isolation that made it necessary. So, if you're a junior engineer and you find yourself building something that seems complicated and nobody has checked in with you in a while, go find a person with the words. Ask them to spend an hour with you before you spend 2 days. The construct you're looking for probably already exists. It probably has a name. And the name is probably going to make you feel slightly foolish and also massively relieved. And if you are a tech lead and you have junior engineers and you've been busy, go check on the whiteboard. Not to supervise, just to give them the index entries they don't have yet. Newton and Leibniz did fine without each other. They also both had access to the mathematical tradition of everyone who came before them. They were standing on shoulders. We were standing in a conference room floor with a missing marker cap, building something that had existed since Dennis Ritchie was in grad school. Give junior engineers the shoulders. That's this episode of Chaotic Commits. I'm Joanne. Find me wherever you get podcasts. I'll see you next episode. The marker cap status, unknown.